Okay, so we're going to go through the January 2022 1HR Edexcel iGCSE paper. Here goes. So, write down all the values of n such that -2 is less than or equal to n, that's what that extra equals there, is less than 3. So -2 is allowed, and then we've got to be bigger than -2, so that's -1, 0, 1, 2, but not 3. And we know that n is an integer, and that means in a whole number. Okay, on the number line represent the inequality y is less than or equal to 1. So it's equal to 1, which means we have a solid dot, so we allowed the 1, but it's less than or equal to, so it's all the things this way, and we put a little arrow to indicate that we can keep going that way. Okay, question number 2. Each time John plays a game, the probability he wins is 0.65. John is going to play 300 games. Work out an estimate for the number of times that John wins. So that's kind of like doing 65% of it, or 300, and we just multiply by 0.65, making sure that we write down our working, and we can just type that into our calculator. Is 195. Okay, we'll work out, we've got 3 identical right angle triangles and a square. Work out the perimeter of the shape. So we know that that length, there to there, is 12.8. So the key length we need to find out is this one here. So let's call that x. And we know by Pythagoras, because we've got a right angle triangle, x squared plus 12.8 squared equals 16 squared. So x squared 16 squared minus 12.8 squared, which we can work out. Squared minus 12.8 squared is 92.16. So x is the square root of that. Which is 9.6. So we now want the perimeter of the shape, so that's going to be 9.6. That's going to be 9.6. We've got that 16, we've got that 16. So it's then just this one here, and this is going to be 12.8 minus 9.6. Okay, so the total perimeter equals 123 times 16 plus 9.6 plus 9.6 plus 12.8 minus 9.6, which equals 70.4. centimeters. There we go. Okay, question 4. Copy and complete the table of values for this. So the key with this is how we put it in our calculator. So for the -2 one, I'll just write out what you've actually got to type in your calculator. You've got to put brackets around a -2. Otherwise your calculator doesn't realise you're squaring the negative. -4 times -2 plus 3. Okay, so you've got to do that for each of them. So that will come to 15. 1 will come to 1. Come to 0. 2 will come to -1. And then there should be some symmetry, but we'll just check it. 4 squared minus is 3. So yeah, we can see that symmetry coming on. Got a quadratic, so we can see it's going down and then back up again. Okay, on the grid draw the values. So 2 is at -2 is at 15. You can draw these more accurate than me, I think. -1 is 8. 0 is 3. That wasn't very accurate. 1 is 0. 2 is -1. 3 is 0. And 4 is 3. And we can see we've got that U-shaped curve. Okay, draw the graph. So the graph is what fills in all the values that we haven't plotted, all the decimal values. We're going to join it with a smooth curve. Hopefully you'll be able to do it even better than mine. Okay. Yusuf sat 8 examinations. Here are the marks for 5 of them. Mode mark is 80. Median mark is 74. The range is 16. So he's at 8. 1, 2, 3, 4, 5. So we've got 5 of them. I'm going to put them in order. Got 68, 72. Now we know that it's median. We know the mode is 80, so we know that there've got to be 2 80s at least. Let's assume there are going to be 2. The range is going to be 16. The range is going to be 16. 75, 77. Now the median is going to be 74. So if we put 74 in as the middle one, then we need 4 on each side, which means we need 9. So we've got to have a 73 here to make that 74 in the middle. So 74 in the middle, and then there's got to be that's the middle of those two. So there's got to be 4 on either side, and it's got to be 16 less than our 80. So it's got to be 64. So so the missing marks then are 64, 73, 80. I hope you can follow what I've done there. Okay, the lowest common multiple of 36 and 120. So lowest common multiple, it's easier to to kind of work out the factor trees and then do it from there. So we've got 3, let's do 2s first of all, 2 and 18, 2 and 9, 3 and 3, and 120 is 2 and 60, 2 and 30, 2 and 15, and 3 and 5. So 120 is 2 to the power 3 times 3 times 5, and 36 is 2 squared times 3 squared. Now I'm just going to write these in a little Venn diagram. Helps. So the things that are common, there's 2 2s and a 3. What's left? There's a 3 in this one and a 2 and a 5 in this one. So the highest common factor is the bit in the middle, but we want the lowest common multiple, which is actually just all of them multiplied together, because then it's a multiple of all of them. So that is going to give me, if I multiply those together, 360. Okay, and that's the lowest that is a multiple of both. Okay, let's just zoom in a little bit so we can see these. Okay, A is 5 squared, 7 to the 4, 11 to the p. P is that, where m, n and p are integers, whole numbers, such that m is bigger than 2, n is bigger than 10, and p is bigger than 1. Find the highest common factor of a and b. Give your answer as a product of prime factors. So we're doing the highest common factors. So we're doing what's in the middle. Well, if m is bigger than 2, then there's definitely going to be 2 5s in the middle. If n is bigger than 10, then there's definitely going to be 4 7s in the middle, so 7 to the power 4. And if p is bigger than 1, then there's definitely going to be 1 11. So the highest common factor is all the things in the middle, which is 5 squared times 7 to the power 4 times 11. There we go. Okay, Millie went on a car journey. She travelled from Annecy to Bray to Clando, then to Duckbridge. From Annecy to Bray, Millie drove 200 in that time. Then she drove at an average speed of that. Then she drove at that. What is her average speed? So average speed, we need the total time and the total distance. Average speed is the total distance kilometers per hour divided by the total time. So the total distance, okay, well, we've got to work out, in this one we've got to work out the time, and in this one we've got to work out the distance. So here the time is distance divided by speed. It's 220 divided by 80. Which is 2.75. And this one we've got to work out the distance, and distance is speed times time. Oh, it's 50 minutes. So 50 out of 60, because we want it in hours, is 60. So the total distance is 245 plus 220 plus 60, and the total time is 2.5 plus 2.75 plus 5 over 6, or 50 over 60. Add that together, 245 plus 60, 5, 2 plus 2.75 plus is 6.083 recurring, 525, using the exact value, that is 6300 divided by 73. We want it to one decimal place, so that's 86.301, so that's 86.3. Okay. Write this as an ordinary number, so 10 to the power 4, so that's 5 times 10 to the power 4, 10 to the power 4 is 1, 2, 3, 4. Is that, so that will be 50,000. Now we don't have to write the commas in, becoming more standard just to leave a little bit of a gap. Write the following in standard form. So standard form, the first number must be bigger than 1 but less than 10. So we move the decimal point until we get that. So we divide by 10, divide by 10. 1, 2, 3. So just so you can see me doing it here. 1, 2, 3, 4, 5. So we've got 6 times 10 to the minus 5. So we'd have to move it 5 back to get there. So let's put it on the line. 6 times 10 to the minus 5. Now with these ones, I would put it in your calculator. Just make sure that you put the brackets round all of it. 4 times 10 to the power 512 divided by 1.6 times 10 to the power 700. And they pick numbers that are too big to put in your calculator. Okay, so we've got to go 4 times 10 to the 512 over 1.6 times 10 to the 700. So we can divide the 10s and divide the 4s. So we get 4 divided by 1.6 is 2.5, and then divide the 10s, we're going to get 10, we're going to subtract the power, so we've got 512 minus 700 is minus 188. Is this number 2.5 bigger than 1 and less than 10? Yes, quite often it isn't when you do this, but it is in this case, so we're all good. 2.5 times 10 to the minus 188, which is clearly too big, or in fact too small, to put in our calculator. There we go. Okay, first row of the paper done. Okay, simplify this. So this is x times 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 x. Now you don't need to write all of that out, but you can see, and hopefully that makes sense, as to why there are an n x to the 9. Okay, this is 4y squared times 4y squared times 4y squared. So that's going to be 4 times 4 times 4, that's 64. And without writing all the y's out, you can see you've got y squared times y squared times y squared, so you can have 6 of the y's, so you can have y to the power 6. And then factorise this. So we're going to put into double brackets. So we know it's got to be an n here and an n here to get the n squared. And we know it's going to be, we don't know. It could be 6 and 2, 12 and 1, or 4 and 3. They're either both positive or both negative. To get the positive, we want to get a negative 7, so they're probably both going to be negative. So we're going to put both negative there. Well, they're definitely going to be both negative, and then I can see that that's going to be 4 and 3, because that's going to give me my 7. So we've got n squared minus 4n minus 3n plus 12. So I can check that and see that it's right, and we're all good. Okay, question 10. Jonty has a storage container in the shape of a cuboid. Shown, Jonty is going to paint the outside of his storage container apart from the base. He needs enough paint to cover the 4 sides and the stop. Each paint covers that. The cost of it is recently increased by 10%. After the increase, the cost of each painting is that. Jonty says, before the increase, I could have bought enough paint for less than £200. Show that Jonty is correct. Okay. Well, the first thing we need to do is work out the area to paint. Which is the ends, so 3 times 2.5, and there are 2 of them, plus the 2 longer sides is 12 times 3, and there are 2 of them, plus top, which is 2.5 times 12. And we can add all those up. Is 117. Is the area. Then, so each paint tin covers an area of 15, so number of tins is 117 divided by 15. Is 7.8. So therefore 8 tins because we can't buy part tins. And then we need to know the cost before the increase. So we know that after the increase, we know that 110% after the increase is £26.95. So can I do this in one go? Yeah, to get 100%, I need to divide by 110 and then times by 100, or divide by 1.1. So 26.95 is 24.50. You can check that that's correct by adding 10% onto it and check that you get the right answer. So 8 tins, 8 times is £196, which is less than 200. So John T, correct. Don't miss out that final step of just kind of stating that he is correct. Oh, there's a bit more space up there. Managed to fit it all in. Okay, the sector of a circle. Calculate the area of the sector. So it's a whole circle, but a fraction of it. So it's that fraction of a whole circle. The area of a circle is pi r squared. So pi times the radius, which is 7.1 squared. It's 48.3901. We want it to one decimal place, so that's 48.4. Expand and simplify. Okay, I would always do the harder one first, so I'm going to expand this one first. That's 3n squared minus 12n plus 5n minus 20. Combine that together. 3n squared minus 7n minus 20, and then multiply through by n. 3n cubed minus 7n squared minus 20n. Okay, express this as a single fraction. So we need to have a common denominator here. And I think the easiest common denominator is 4x, because everything goes into 4x. If we just have 4x, for the first one we've got to multiply the top and bottom by 4, so that'll be 12 over 4x. Next one we've got to multiply top and bottom by 2, so that's 2x plus 2 over 4x plus, got to multiply top and bottom by x. Okay, hopefully you can see that's the same, and then that then becomes relatively trivial to add up all the different bits. So we've got 14 plus 3x over 4x. And that is as simple as we can make it. If we had picked a bigger number, so if we'd multiplied them all together, for example, and got 8x squared, we'd have had to do some cancelling at this point to get down to the 4x. But it's still doable like that. Okay. Hector has a bag that contains 12 counters, 7 are green, 5 are red. Hector takes a counter from the bag. He looks at the counter, puts the counter back into the bag, then takes a second counter. He looks at the counter and puts it back in the bag. So, green is 7 out of 12, red is 5 out of 12. Green is, for the second counter, 7 out of 12. Red is 5 out of 12. And actually it doesn't matter which, 5 out of 12. Doesn't matter which route you're going. Work out the probability that both are red. So that's this route here. 5 over 12 times 5 over 12 is 25,144. Okay. Megan has a jar containing 15 counters. There are only blue counters, green counters and red counters in the jar. Hector is going to take at random one of the counters from his bag of 12 counters, look at the counter and put the counter back in the bag. Hector is then going to take a second counter in his bag, look at the counter and put the counter back in his bag. Megan is going to take at random one of the counters from her jar of counters. She'll look at the counter and put it back into the jar. Find the probability that the three counters have a different the probability the three counters have a different colour is 7 out of 24. Work out how many blue counters there are. So, okay, so the route to get a different one is we've got to get green and red and then blue, or we've got to get red then green then blue. And those are the two routes. And those two are both the same. So we've got 7 over 12 times 5 over 12 times x, the number of blue. So let blue equal x over 15. And that's actually exactly the same, so double that has got to equal 7 over 24. So if I multiply all the top of that, I've got 7 5s are 35, so I've got 70x over 2160, so that equals 7 over 24. So I divide both sides by 7. So I've got x equals 216 divided by 24, which hopefully will give us a whole number, and it does. It's 9. So there we have 9 counters. Okay, that required a little bit of thinking about. I hope you can follow what we've done there. Okay. A, B, C, D are points on a circle, centre 0. So centre 0. AOC is the diameter of the circle, i.e. it's a straight line. BAC is 55. Work out the angle ADB. ADB, so we want this one here. Okay, so it says give a reason for each stage of your working. So I think we're just going to write down what we know. Because that is a diameter, that is a right angle. So angle ABC equals 90 degrees as, technical word is subtended from a diameter. And then that means that this one, because we've got a triangle, is going to be 90, so that's going to be 35, because so angle BCA equals 35 degrees, and that's because angles in a triangle add up to 180. So, to 180. And then we've got these two are from the same chord, so they're in the same segment, so we say that angle BDA also equals 35. Angles in the same segment are equal. There might be other ways of doing it, but that I think is the most direct way, and you've got to have those 3 reasons to get all 4 marks. Okay, using algebra, prove that given any 3 consecutive whole numbers, the sum of the square of the smallest number and the square of the largest number is always 2 more than twice the square of the middle number. Okay, let n minus 1 n plus 1 be any 3 consecutive whole numbers the sum and square of largest and smallest equals n minus 1 squared plus n plus 1 squared, which is n squared minus 2n plus 1 plus n squared plus 2n plus 1, which is 2n squared plus 2, and twice the square of the middle number, square of the middle number, equals n squared, twice square of middle equals 2n squared. Therefore, statement is true. Okay. Okay. Arithmetic series has the first term 1 and the common difference 4. Find the sum of all terms of the series from the 41st term to the 100th term inclusive. Okay. So, there are a number of ways of doing this, but I think the easiest is probably to say, okay, let's do the first 100 terms and then take away the first 40 terms. So we're going to have 100 over 2, 2a plus 100 minus 1 is 4 minus first 40 terms, 40 over 2, 2 times 1 plus 40 minus 1 times 4. So that's going to be 52 plus 4 times 99 minus 20, 2 plus 4 times 39. And work out that is 16740. Okay, next row done. So it must be about 2/3 of the way there. Okay. The Venn diagram shows the universal set E, that means the square, and 3 sets A, B and C. 6, 3, 8, 2, 5 and 4 represent the numbers of elements, that's really important, the numbers of elements in each of the regions. Find the number of elements in A union B. A union B, let's just do these in colours. So A union B is all of A, all of B and everything in between, so it's all of that. So that's going to be 10 plus 9 is 19. Okay, the number in A intersection C, A intersection C, A intersection C, A doesn't intersect C at all. So there are no elements there. B intersection with C dashed. So it's got to be outside C and in B. So it's going to be that region there. So there's going to be 11 of them. And then the last one, the union. So outside A dashed, outside B dashed. So outside A dashed is this 6. Outside A dashed are these. So A dashed, sorry. B dashed includes that one as well. And C dashed includes that one as well. So this is all the values, which if we add them up, 11 and 5 is 16, 20, 28. There we go. Okay, question 18. The three solids A, B, C are similar, mathematical word meaning enlargement of each other. The surface areas surface area of A to surface area of B is in the ratio 4 to 9. So I'm already going to be thinking that the length of A to the length of B is going to be the square root of that, so that's 2 to 3. And B, the volume, so this is going to be the cube root, so the length of B to the length of C is going to be the cube root of that. So that's 5 times 5 times 5, so that's 5. And that's 7. Okay, work out the ratio of the height of A to the height of C. So I could multiply, I want to get B to be the same. So I could do something cunning and say that this is the same as the ratio 10 to 15 and multiply this one by 3. This is the ratio 15 to 21. So what I've got there is I've got a ratio now A to C of 10 to 21. Okay, 19. Given that, the cube root find the value of m. Okay. So we've got to write these all using the powers that we know about. So we've done this reasonably recently, x to the minus 1, and then we're going to cube root, so that's third, and then we're going to do that to the power 4. We know that we just multiply all those together, so we've got x to the minus 4 over 3. So m is minus 4 over 3. Express this in the form of this. Okay, so we're completing the square. So I'm going to take x squared plus 4x, and because 19 doesn't go very well, I'm just going to leave the plus 19 and we'll deal with that later. Okay, and then I'm going to deal with this bit. So this is 3 brackets x plus 2 squared, but I don't want the 4 that comes when you square that, because I want nothing there, plus 19. So now I've got 3, and this you have to be careful, I've got 3 lots of this bracket, and I've got 3 lots of the 4, which is minus 12, and then I've got the plus 19. So I've got 3 brackets x plus 2 squared plus 7. And the thing I would do with this, particularly because it's got an a of not 1, it's really easy to make a mistake, is just check this. And by checking it, I mean just multiplying it out and checking it comes. So I've got 3 lots of x squared plus 4x plus 4 plus 7. So I've got 3x squared plus 12x, that's looking good, plus 12 plus 7, and I can then see that that's 19. So we're all good. So we write it in the form 3 brackets x plus 2 squared plus 7. The curve equation f(x) has one turning point. The coordinates of this turning point are minus 6, minus 4. Write down the coordinates of the turning point with equation f(x) plus 5. Well, we know that that just moves it up 5. So this is left, right. So up 5, just be minus 6, 1. F of 3x means it's going to be a stretch in the x direction, factor a third, so it's going to squash it in towards, so this minus 6 is going to become minus 2, but it stays the same height, so it stays at minus 4. Okay, on the graph, g of x is shown. Sketch the graph of 2g of x. Okay, so 2g of x means we've elongated everything away. We've doubled all the y values. So let's pick the nice ones. That one's going to be there. That one's going to stay where it is. That one's going to stay where it is. That one's going to double. That one's going to double. That one's going to double. That's going to double. That's going to double. That's going to double. So there we have it. Ooh, I think you'll be able to draw that better than I have there. But you get the idea. Okay. Oh, we've got another. The graph of h of x intersects the x-axis at 2 points. The coordinates of 2 points are such and such. The graph of h of x plus a passes through the points of coordinates 2, 0, where a is a constant. Find the 2 possible values. Well, so we're moving either one of those points. So we're either moving it 3 to the right, or we're moving it 4 to the left. So 3 to the right will give me -3, and 4 to the left will give me 4. So our two different values are -3 and 4. Okay. The histogram gives information about the weights in kilogram of all the watermelons in the field. There are 16 watermelons with a weight of between 8 and 8.5 kilograms. Work out the number of watermelons in the field. Okay, so it's telling us about one of the scales, and we've got to use that then to work out all the others. So we know that the area, 8 and 8.5, we know the area of this is 16. So that's 8.5. So the width of this is 0.5. So to give an area means that must be 32. So they've actually made it quite nice, because then that's each individual square. So that's 10, 20, 30, exactly. Okay, so we've now got to do all of them. So we've got to do 1 times 15 plus, well, we know that one's 16, plus 1 times 23 plus 1 times 30 plus 1.5 times 12. Add that all up. We get 102. Okay, the diagram shows this. Calculate the upper bound for B. B is that, so B so we know that non-right angle triangle, so we know the sine rule, we know that that's really mean. We know this one is 180 minus 80. So the nearest whole number, so minus 80.5 minus 70 5.5. So it could be that or it could be 180 minus 79.5 minus 74.5. So this will be the largest it could be, 180. Will be 26. So that has got to be between 24 and 26. So then we want the upper bound for the value of b. So we know that b over sine b equals c over sine c equals c times sine b over sine c. So we want upper bound, so we want big value for c. So that's one decimal place, so the biggest that can be is 11.55. On a big value for sine b, and sine is increasing, so we just want a big value of b, so the biggest value of b is 26, so sine 26 over sine, and we want a big value of little b, so we want to divide by as small a number as possible, so sine c is y, is small value of y is 74.5. Which is 5.25, etc, etc, etc. We want it to 3 significant figures, so that's 5.25 to 3 significant figures. There we go. Well, we've got 2 questions to go. Two particles, P and Q, move along a line. The displacement of displacements, so that's distance of P from O at time t is s meters, where that's that. Displacement of Q from O is that. Find the range of values for which both particles are moving in the same direction. They're moving in the same direction. So moving is about their velocity. So for this one, the velocity is 3t squared minus 8t plus 5. So that's the velocity of P. And then the velocity of Q is 2t minus 4. They've got to be moving in the same direction. So we kind of want to find out when they're when they're both positive and when they're both negative. So let's solve 3t squared minus 8t plus 5 equals 0. So we can have 3t. Let's hope they pick some nice numbers. I think they have t 1 minus 5t, yeah, equals 0. So t equals 1 or 5 over 3. And VQ equals, so that's when VP equals 0 when, and VQ equals 0 when t equals 2. So this is a positive. So if we think about just sketching that, 1 and 5 over 3, so do something like that, and this one, when t is 2 and it's positive, so they are moving in the same direction. So after 2 they're both positive, and below 1, in fact between 1 and 5 over 3, so t is bigger than 2, they're both moving in the same direction, and they're both moving in the negative direction between 1 and 5 over 3. Okay, that's quite tough, but I hope that makes sense to you. So direction, it's all about differentiating velocity, then it's looking when they're the same direction, so when they're either positive or negative. Okay, back to the question. M is the midpoint of OX. N is a point such that MNZ and ONY are straight lines. Okay, as the diagram implies, given that ON to OY is lambda to 1, OY is 1. Oh. Okay, that's fine. Use a vector method to find the value of lambda. So my guess is we're going to have to find 2 different routes to do this. We know that OX is A, so I'm going to go from O to N equals lambda O to Y, which is lambda A plus B. Okay, but ON is also O to M plus mu lots of M to Z. OM, that's easy, that's A over 2 or half A plus mu M to Z is minus half A plus 3B. Okay, so we've got two different roots there, so we can now just compare them. So we've got lambda A plus lambda B equals half minus half mu A's plus 3 mu B's. So now comparing the A's and the B's, we've got lambda mu, and we've got lambda equals 3 mu. Now, although we actually want lambda, I think it's easier to rearrange this so that we get rid of the lambdas. So we've got a half minus a half mu equals 3 mu. Take that over, half equals 6 over 2, 7 over 2 mu. So mu equals 1/7. So lambda equals 3 times 1/7, which equals 3/7. There we go. There we have it.